Hi, and welcome to another Hopper 6502 video. This one's not really a Hopper video, more of a 6502 video. This is where we left off in my previous video. If you haven't watched the one on these LED things from Digicool Things, you can watch that to understand what the circuit is. It's a no-op tester, pretty common for 6502. And what I'm going to do with this video is I'm going to talk about a pretty cool device, this one. So what is it? So many years ago, Steve Wozniak came up with this single-step circuit for the 6502. Just uses two flip-flops, TTL chips, and takes advantage of the sync pin and the ready pin. There's a couple of reasons why this is not the complete circuit. Like our modern chips, our CMOS chips, they'll have like a HC in there or an LS or something, and you need to ground all the unused pins, which this circuit doesn't do. And there are a couple of other things. So the device I'm going to show you is this one. It's Anders Nielsen's reimagined version of Steve Wozniak's circuit, where he's made the changes necessary for like the HC chip there, which is CMOS chip. So he's tied the unused pins low. And interesting thing about this single-step approach, which is different to the more common ones we've seen recently, like, for example, Ben Eater's clock, is the way Ben Eater gets a single step is he actually literally slows the clock down to one clock pulse at a time. But in theory, that doesn't work for the original 6502s because they're not static. So if you stop the chip, it'll lose its registers. This one instead takes advantage of the ready pin, which is what the ready pin was designed to do. So you can stop the chip without stopping the clock. So the clock pulse is still going, and that can be used to refresh the registers on the older 6502s. It also takes advantage of the sync pin. What does the sync pin do? Sync goes high on the fetch cycle. So common misunderstanding, one clock cycle does not equal one instruction. So most instructions use at least two clock cycles, possibly more. And sync going high happens on the fetch cycle, which is the first cycle. So this means you can choose to step either on cycles or on instructions. Let's have another look at what that means. So for example, the no-op instruction, which is what our tester is using, uses two cycles. If you look at other instructions like logical shift left, it can use quite a lot of cycles depending on which addressing mode you're using. And that's because the CPU can only access the data bus, once per cycle. And to do things like get an address, to get a 4-byte address, that's gonna take a couple of cycles. And then it's going to have to read it and write it because it's shifting something left. It's going to have to read it, shift it left, and write it. So that's 2 bytes. That's, so 7 cycles to read the address, read the data, write the data. And also it would have had to originally read the instructions. That's where you get your 7th cycle. Anyway, you can step in and the typical single-step circuits that only use the clock would have seven clock signals for this one instruction, right? Whereas we actually just want one step of our single step to get past that, right? Okay, so let's go see what this looks like. So there's Anders's board, very nice, and I wanted to use it flat on the table like this so that I could press the buttons easily. I didn't want it sort of mounted in. I didn't want it mounted on pins in the. I didn't want it to be mounted on header pins in the breadboard. So to do that, I cut a piece of some jumpers like that. I always make sure that my red and black are what you expect the power to be. So I chose some jumpers that had red and black on them. Now, this is the circuit I built last time, and let's just power it up. So it's going to once it's been through the reset cycle, it's just going to be counting in binary here, right? And my clock cycle time is 50 microseconds, so very slow. And I've changed the built-in NeoPixel. If I reset, it's going to do the first 25 reset pulses in purple, and then it's going to switch to blue for the clock cycles, which means I don't need my reset or clock LEDs anymore, so we can get those out the way. Now, I tied ready to high with the 10K resistor, and I did that for a reason. I mean, I could have used a smaller resistor. I could have just hardwired to positive, but the reason I didn't is because I wanted to do this. So now I can come in here and just so ready is yellow. I can just put that straight in there without having to change the circuit at all. And the next one across this clock is that one, and the brown goes to the sync. So that's so that we can know when the which cycle is a fetch cycle. Okay. And then the power goes into the power rail. And let's have a look at that. There we go. All wired up. So I didn't have to change my design at all. I didn't have to change my circuit. So, and this will work. You could do this straight onto an existing computer, and most of the time it'll work, assuming your ready cycle hasn't been tied high. And so let's mount it up there like that. And let's plug the power back in. Let's see what's going on. All right, I'm gonna switch that off and reset it. There we go. I didn't know which way it was set. So this is doing exactly what it was doing previously. It's just doing this binary count on the address here, right? And now this button on the left is called run. So if I press that in, it'll stop running. If I let it out, it'll run. And now I can press this button to step. And there we go, we're counting in binary. So you can see, let's see, counting in binary there on each one. And then if I switch from here, it's got cycles versus instructions. Now it'll be similar to like Benita's single step, which is going to be 2 steps per no op. So I have to go 1, 2, sorry, halfway through. Let's go 1, 2, 1, 2. So I'm doing 2 cycles per no op. If I push it in again, now I get one press per instruction. And then I can let it off the hook again by just putting it into run mode. There we go, now it's running again. Anyway, short video. Makes more sense if you've seen the other one. I'll put a link at the end to it. But very, very cool little device here from Anders. Really nice. Really simple to plug into. And so you can take any of your 6502 development projects and instantly add single step to it. So thank you for watching.